everyone, and welcome back to the part 2, and here we will be seeing a few more examples, more quantitative analysis, and we will also see that how much time it would take to get effects of these recharge. So, in order to bring quantities in our approach, the discussion which I had about the reservoir area and benefit area, here we are defining that the reservoir area, the inundated part or water body, we consider as a submerged area as shown here, and in the downstream area which we can identify on satellite images through delineating the growth of vegetation, that we can call as benefit area, as you are seeing here. So, this is the basically reservoir is there. This is of course a schematic, and in a watershed or in a basin, this is what is the scenario which we will see further. So, keeping this benefit versus submerged ratio and analyzing existing reservoirs in that Bundelkhand region, which is a hard rock terrain, in Bundelkhand gneissic complex region, hard rock terrain, we could identify that there are reservoirs like the first one, which is a Chanderi reservoir, falls in Madhya Pradesh of Bundelkhand region. It is having this benefit versus submerged ratio is 28.18, and whereas reservoirs like Jamalpur in the bottom, which is having the benefit versus submerged ratio is 0.66. So, this B oblique S ratio, BS ratio is very little. That means if I go for if I construct a reservoir near or in the area where Chanderi reservoir is currently located, then I am going to have about 28 times of benefit, 28 times benefit in terms of the area. That means if I submerge 1 square kilometer of the area to construct a reservoir or a dam, then in the downstream I might be getting a benefit area of 28 square kilometer. This is what this ratio means. Whereas I am getting this like example of Jamalpur reservoir, where if I invest 1 square kilometer area for construction of a reservoir, then in the downstream only 0.6 square kilometer of area is getting benefited. So, that means that this area is not good for further development, but what if we say we fix a threshold, say around 10, if I invest say 1 square kilometer of land, I should get benefit at least 10 times, or 10 square kilometer of downstream area should get benefit of groundwater recharge. So, if I fix this threshold, large number of area of Bundelkhand region or large area of Bundelkhand region, through these reservoirs we can know beforehand that how much return I am going to have in terms of benefit area. So, analyzing satellite images, anyone can develop such a benefit versus submerged ratio for a particular area, say for Gujarat part or Maharashtra part where a lot of water problems are there, or in South India, and looking at the satellite images, identifying a water body, a reservoir, and the downstream area which is getting benefit, and creating such ratio. Now, in the vicinity, if suppose a reservoir is located here, which I am seeing, then there are possibilities of getting construction of reservoir elsewhere, then I know that what kind of return I am going to have. So, 28 times is a very good return in terms of benefit area in that particular area. So, even a 10 times is no way is bad. So, such kind of benefit versus submerged analysis before any such structures are constructed can be done. Now, I also mentioned that it will take 2-3 years time in hard rock terrain to get the benefit, because the hydraulic conductivity, that means the water from in subsurface condition, in groundwater condition, will flow from one end to another in a very slow pace. This is what we say hydraulic conductivity, and it takes years to reach to few kilometers or to go through few kilometers, because it depends on the fractures in the rocks or weathering zones in the rocks, because this is the example which I am taking is a really hard rock terrain. So, only the top part is you are having, which is weathered and fractured, and it is having unconfined aquifer condition. So, whatever the water which you can store is only in the top few meters, say a maximum 10-15 meters. Below that you are having very solid granitic rock, and therefore, there is no chance of storing water there. So, it is better to store water as far as possible in the top layer of this hard rock terrain. See, there one reservoir which was under construction, which is called Rajghat reservoir, or also called Rani Lakshmi Bai reservoir. And you see in 2001, these are the MODIS images, and which are available on daily basis. Though resolution is 250 meter, does not matter for such kind of a study. And what you see here, a reservoir was just started filling in 2001. And see, in this is a true color image, therefore vegetation will appear in green color, and you do not see any growth of vegetation. But you come next year 2002, and you in the downstream of this reservoir you start seeing the growth of vegetation. When you go in the next year, that is in 2003, and this is what you are now started seeing, that in the downstream area large part is getting benefited. And in just 3 years time, the entire area is now green. This is watershed or the ridge. So, therefore, you do not have much effect of groundwater recharge induced by this reservoir, but in remaining areas you are having. So, this large part is now has, just compare this one with 2001, hardly there were any growth of vegetation. So, at that point I can, and this is the point which I am trying to justify, that it takes about 2-3 years time in a typically hard rock terrain like in Bundelkhand region to get the benefit. So, hydraulic conductivity is not very high, it is slow, but nonetheless you can get benefit. So, if some measures are taken today, then in 2-3 years time we will start getting benefits. Someone can argue on this image that probably it is because of the 2001 might be pre-monsoon and 2002 might be the post-monsoon, and or 2004 image which is shown here might be post-monsoon, and therefore lot of differences are seen. It is not true. So, what I did, I got the same dates data of different years, completely cloud free data, almost completely cloud free data. So, this is 2002 which you are seeing, then this is 2004, 17 December, same 17 December 2013, and you can see that in only in 2001 or 2 this reservoir started getting filling and water, and the benefit area started developing, and in 2013 the entire region has got greenery there. So, this greenery is really coming because of groundwater recharge through a large reservoir. Though this reservoir is multi-purpose reservoir, and there is a lot of other purposes are there, like for example, it is also having the hydropower, it is also having lift irrigation, canal irrigation, all those things are there. Another important point which I want to bring is that if you see this channel here, if I mark that this channel, this is Betwa river. So, there is already one reservoir here which is called Mata Tila. This is the reservoir which is called the Rajghat. So, what we need to do now, that wherever possible construct reservoir in cascading fashion. That means the one tail of one reservoir ends, another reservoir after just 1 or 2 kilometers can be constructed like here, and it will have its own tail like this, and then you are having another reservoir and likewise. So, whatever the rainfall, which is quite good, in this area the average rainfall is around 950 millimeter per year. So, whatever the rainfall which we are having and whatever the surface runoff, we can store through these cascading one reservoir after another in the same on the same river system, and we can store lot of water, we can delay the groundwater, we can delay the surface runoff, and therefore we will allow a force groundwater recharge. and in just 2-3 years time the entire area can have benefits of that. The water will be available in form of groundwater, and then farmers can fetch that water very easily. So this is what is need to be done, that wherever possible construct, may not be large reservoir. I am not saying anything about the large reservoir, maybe small reservoir which does not require much time to construct, maybe in 6 months or 2-3 years, 2-3 months time, with local material, with local people, and construct such reservoirs on small streams, and that too in cascading. The tail of one reservoir ends, another starts, and so on and so forth. And when the monsoon will come, all these will be successive reservoirs would be filled, and then they will recharge groundwater regime, and the benefit will start coming in 1 or 2, 3 years time very quickly. So this is the what advantage of water in a dry land. If I bring the same example of Rajghat, this is Landsat MSS image in Landsat image here, and what vegetation is appearing here green, and there is no water so far. It was not really under construction, because it took 30 years for construction. It is a large reservoir. So there is not much growth of vegetation, and in 2002 that was the only first year of filling of that reservoir, and you can see in the downstream area the benefit has started coming. So large area gets the benefit. Rather than going for large reservoirs which takes lot of time for construction, it is better to go for smaller reservoirs like these. There are many such reservoirs, and in the cascading fashion, like the one is here, one can be constructed here, one can be constructed here, and likewise cascading fashion, and lot of benefits can be, the advantages can. This stream is still having lot of possibilities. This Betwa river is having lot of possibilities of having reservoirs. So a reservoir can be constructed here, then tail of one reservoir will end, another one here like this, and series of reservoirs can be constructed. And what I am trying to say, that whatever the water which comes in the form of rain or precipitation should be stored first as a surface storage. Very quickly it will go, in few months time it will go in the groundwater regime. There will be some evaporation losses, let it be, otherwise you are 97% of water you are anyway losing as a surface runoff. So if through this reservoir, if I am getting 15%, 20% loss as evaporation loss, does not matter, because ultimately I am going to recharge groundwater regime. And if canal irrigation and other irrigation systems can also be developed, that would be wonderful. But small reservoirs and cascading reservoirs, successive reservoirs on a stream can solve the groundwater problem in the country. This is just to let you know a field photograph where a few years back, before the construction of Rajghat Dam, there were no water, no vegetation, and such joy of water was not there. And once that reservoir came, a small canal passing through a village, and you can see the joy. Not only humans are enjoying the benefits of water, but the animals too are enjoying the benefits of water. So water is so important in this part of, or in many parts of the country. More than 54% of the part of the country is suffering or in the deficit of groundwater. Now I will take this Bundelkhand region as a whole, and how with the help of remote sensing and GIS we can do further work on this. So very quickly I will go through this, that what we have done, we have analyzed this entire data set of Bundelkhand region, which is a big region, and then we have identified those quartz reefs which are running northeast southwest direction, and there are many quartz reefs, and some of them are running for hundreds of kilometers. As you can see that this is 50 kilometer scale, so they see these quartz reefs are running for very long distances. Part of them is exposed on the surface, which can be mapped easily through satellite images. Part of them is not exposed, does not matter, but we can know that there are the quartz reefs, and there might be some streams which might be flowing in this one, which the streams are flowing like this and completely unchecked, as I have marked in the blue color. And if by some means if we can check where these dam axes have been provided in form of quartz reef, then we can construct a reservoir very quickly. This is what our ancestors have done, and that will provide the delay in the surface runoff, and of course indirectly that will provide the groundwater discharge. If I see a field photograph of an area, this is the satellite image. So, from satellite image on high resolution, even using Google Earth images, we can see that a stream is going through like this, and the quartz reef is running again in northeast southwest direction. This is the field photograph, and the height here is 25 to 30 meter. So, this is a natural, you can say natural dam, and if by some means if we can block this part, then automatically I get a dam very quickly, a reservoir very quickly, and can upstream part of this can start getting inundated in next monsoon season, and benefits will start coming in 2-3 years time. Like ancestors have done, the quartz reef is running like this, reservoir was constructed, and the benefit you are seeing in the downstream. Similarly here, a quartz reef is there, it was blocked, stream, and then you are having reservoir, and the surroundings is getting green. And so likewise hundreds of such sites can be located using remote sensing data only, or along with maybe like shaded relief model derived from digital elevation model, and almost all these data sets are available free of cost. So, one need not to buy anything, just go on internet, download the data, analyze the images the way I have just demonstrated to you, and you start, and then of course the construction is required. So, if we lot of such sites which are marked here with the red color have been identified here, this which you are seeing, they have been identified like this, and the red color which you are seeing here, and one site the zoom part of that site is there, that this is the proposed dam axis, and the remaining is the quartz reef. A stream is flowing like this, and then if it is checked, then a dam will come in few years time. Now, employing GIS and employing a digital high spatial resolution digital elevation model of this area, we can even simulate a reservoir before its construction, and this is what exactly it has done. That once we have decided that the reservoir which is marked here as red will come, then this is how the profile will look, and if we decide the height of the reservoir as shown here with the blue color, then what would be the inundated area and upstream, that can also be modeled, and this is what it has been done through this dam simulation on a GIS platform. Things can also be checked in the field, that whether whatever it is being done on the computer, it is possible on the ground or not, as done in this case. And also you can not only calculate the total volume of water which would be available, but many other parameters which are required for civil engineers, like wetted perimeter and many such parameters which I will be showing very quickly, like inundated area, perimeter, water level, dam height, maximum storage capacity. All those things can be predicted, can be estimated before a reservoir comes, and then decision makers can take appropriate decisions. Once that is there, also some other things can also be done, like using latest satellite images, maybe of relatively high spatial resolution or moderate resolution. We can also prepare land use map, that if at all a reservoir comes in this part of the country, then what is going to be the inundated area, how much area and which area, whether it is inundation will happen in the agricultural land or in a wasteland or in a built up land, and if choice is there, then we can shift this reservoir elsewhere where we will have less disturbances for human and more benefits. So, doing such simulations on GIS platform, we can decide the best sites for identification of groundwater recharge. Also, we can also know beforehand all those parameters which are required to decide about a groundwater recharge structure like a small check dam, and also we would know what land use we are going to submerge in the submerged area. So, likewise such analysis beforehand can be done. This kind of modeling is possible. One example I am showing here. And if this is done, then as I have been saying that in 2 to 3 years time in hard rock terrain like Bundelkhand region, the problem of water can be solved quite easily. And so what are the possibilities of employing remote sensing and to some extent the GIS, so total geoinformatics, that it is possible to identify suitable sites for water harvesting or groundwater recharge. Preliminary assessment of impact of reservoir before construction of such reservoirs is also possible if we employ remote sensing data and gather the knowledge through the analysis of the images of the same area, by which we get the local knowledge, because the knowledge which I get about Bundelkhand cannot be directly applied in say part of Maharashtra or Gujarat. So, for developing a local knowledge, I need to study, one need to study the satellite images of that area where things should be implemented, because here the benefit are coming in a maybe different way, because geological conditions, topographic conditions are completely different. So, therefore, the locally the knowledge should be gathered through should be gained through the satellite analysis of satellite images, and then such assessments before construction can be done. Simple solutions with local people and local material is possible to solve this groundwater problem of the country. So, this brings to the end of this discussion that how remote sensing and GIS or overall geoinformatics can play major role to solve groundwater problem or water problem, domestic water for domestic consumption problem in 2-3 years time, even in hard rock terrain like Bundelkhand or in many parts of the country. So, this brings to end of this discussion. Thank you very much.